Hey there. So, what I want to go over with you right now are some basics that go along with using Google Sheets for statistics. We will be using this for this unit. So, I have created three data sets for you: a red pink set for data set a green set for B, and a blue set for data set C. Some of the concepts that we will be going over this quarter include maximum, minimum, range. You know there are three types of averages: mean, median, and mode. We're going to look at the sample standard deviation and the standard deviation for the population, and the bottom one here is the median. So first, what I'm going to do is show you how to sort the data. So if you look across the top, you will see the words file, edit, view, insert, format, data. And under data, there's a lot of information. So I'm going to unclick this for a minute and go down to the first data set. 5, 6, 3, 7, 4, 3, 5. None of it is any type of order. So I'm going to highlight the pink data set, starting with the 5 and ending with the 2. Click on data, and I want to go down to where it says range from lowest to highest. Sort, even though you'll see A to Z, it also means numbers. So 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. This data set is now in order from least to greatest. I'm going to do that for data set B. Grab the top one, go down to the 34 on here, which I just missed. So I'm going to grab it again. Grab the top, go down to the 34, go up to where it says data, go to sort by range. A to Z is the same as low to high, and 5, 7, 12, 20, all the way down to 84. So this data set has now been organized from low to high. One more data set to put in order. Grab the top, highlight down to the 17, find the word data, go to where it says range. A to Z will put us in the right order. 15, 16, 16, 17, 17, 17, 18, 18, 18, and 19. So the three data sets are quite different than the other, from each other. The first on here is maximum. So we can clearly see that this has a maximum of 7. Data set B has a maximum of 84. And data set C has a maximum of 19. But the data sets will not always be this short if you're doing research. So I would like to show you how to use Sheets to show you how to do this. Just like we did in the first quarter, click in the box under data set A that matches maximum. Start with the equal sign and start typing the word max, M-A-X, and you'll see it come up at the bottom. Click max, and now you need to tell it where you want to grab and what you wanted to check. So from 2 all the way down to 7, let it go, close the parentheses off, and hit enter. And our maximum is in fact 7. Let me show you that again for the next column. Start with the equal sign, and now you're going to notice this Sheets, Google Sheets, is saying, do you want to pick max from D2 to D11? And yes, we do, because that is, if you look around the edges, see all the orange here? That means that's what it has grabbed. Hit equal 84. I'm going to try it again one more time. equal, and you're going to see max already show up from E2 to E11. Look at the orange frame around it. It's telling you that's the area it's grabbing. Hit enter, and the maximum is 19. So it worked very well. I'm going to do the same for the minimum. Start with the equal sign, but now I'm going to type MIN. And you see on the very bottom where it says minimum value, grab from the top to the bottom of the data set only. Don't go any further. Close the parentheses off and hit enter. I'm going to show you one more. Hit equal. And now it's going to show you, see the min right there from D2 to D11? It wants to know if you want that. It will do the same thing again in the next column if I hit equal, except I didn't hit equal that time. So I will get the equal, MIN. Now, because I didn't hit it right away, I have to tell it I want minimum. Grab from the 15 to the bottom blue 19 only, close it off, hit enter. So notice 15 was the minimum, 5 was the minimum, 2 was the minimum. Range is the difference from the highest to the lowest value. So to get the range, I'm going to hit equal, and now I'm going to click in the boxes themselves. This one with the 7 minus this box with the 2, hit enter. I don't know if you remember this from the first quarter, but see this little blue square? If I take my mouse, my cursor, and put it on that blue square, and I pull straight across that row horizontally, it will automatically read the formula. So the range, 7 take away 2 is 5. 84 take away 5 is 79. 19 take away 15 is 4. So those are our ranges. You may recall trying to calculate the mean. You add up all the values and divide by the quantity. So if I wanted to get the mean from this set, I could do 2 plus 3 plus 3 plus 4 plus 4 plus 5 plus 5 plus 6 plus 6 plus 7, hit equal to get the total, hit divide by 10 to get the mean. Or I can just click in here, hit equal. For sheets, you will not find the word mean. You will find the word average, AVER. Go to the bottom average down here. Grab only the pink values 2 through 7. You'll see they'll be highlighted with a little orange box. Close it off. Hit enter. And again, I'm just going to drag the formula. So the sheets does all the work for me. So the mean of the first set is 4.5. The mean of data set B is 34. The mean of data set C is 17.1. I'm actually going to go to the median before doing the sample deviations. The median is the middle value when the data are in order least to greatest. There are 10 pieces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to look at data pieces 5 and 6. 1, 2, 3, 4, 5. 5 is 4. 6 is 5. I have to find the exact middle of 4 and 5 to get the median, which is going to be 4.5. If I go to this next set, we have 24 and 34. So I would have to find what is exactly between 24 and 34. What's halfway between them? It's probably going to be about 29.5. We'll find out for a second. Notice this one, they're both 17, so the median will be 17. I'm going all the way down the median, hit equal, and start typing in the word median, and you will see median. Grab only the pink values, close it off, and we should see about 4.5, and we do. Now let's see what happens when I drag the formula. 29 and 17. So 29 was exactly halfway between 24 and 34. I could add them together, divide by 2, get 29. And 17 and 17 is 17. Standard deviation is sometimes a little bit hard to understand the concept. By definition, it tells us how far out data is spread out. So eventually we're going to look at those bell curves that you've learned. In the bell curve, the standard deviation tells you how far away every one of these values is from the mean. It's the average distance from the mean. So 4 is a half of 1/2 spot away from the mean on a number line. 5 is a half a spot. 4 is a half. 5 is a half. So what this does is it figures out how far is 2 from 4.5? How far is 3 from 4.5? How far is 3? And so forth. How far is 7 from 4.5? It gets all of those distances from the mean, adds them up, and divides by the quantity to give you the average distance from the mean. So it basically tells us if the data is going to be bunched up or spread out. We want the sample standard deviation. So I'm going to put equal and start typing standard deviation, STDEV. So if you look here, we have STDEV, standard deviation. S is for sample. P is the standard deviation of the entire population. Most times we're just going to look at the sample size because that's all we will have access to. I hit that, take the first pink value to the last pink value for data set A, close off the parentheses, hit equal. I could then drag the formula all the way across. So this first one, the average distance that every value is from the mean of 4.5 is 1.6. This last one, where you see the range is only 4, the standard deviation is about 1.2, meaning these are all clumped together. These are very, very tight together. These are pretty clumped together. From 2 to 7, the range was only 5, slightly more than 4. But the range for data set B was 79, which is pretty big. So our standard deviation ends up being 27. That means these pieces are pretty much spread out. It is the average distance all of these data points are from the mean of 34. The standard deviation from the population is going to be slightly different. And you are so fortunate to be able to use something like Google Sheets and not have to calculate this by hand. Start with equal. Start with STDEV, and we're going to see standard deviation. And when we go to the P, it'll say right underneath it, standard deviation of the entire population. Grab the sampling that we have, close the parentheses off, hit equal. We can then take this formula and drag it through the other columns. So if you notice, this is 1.5. The population is slightly smaller than our sample size, and that is usually true. The standard deviation for the population, because it incorporates many, many, many more values, is usually slightly less than the standard deviation of our sample. So if you look at data set B, it's 25.6, which is a little bit less than 27. And for data set C, it's 1.13 compared to 1.19. So there is a slight difference. We'll be using the sheet, Google Sheets, to calculate these values for you so you don't have to figure them out by hand. So you're very fortunate to live in an era where this technology can do a lot of the hard work for you. But then we need to interpret those results. Can you interpret what the results mean? I hope you find this helpful. Bye. Take care.